All right, so this next section, there 7.5 is talking about more trig equations or more advanced trig equations. All right, so let's solve this one here. We got the cosine of a half angle. 2 cosine theta halves equals negative square root of 3. Move the square root of 3 over, divide by 2. Cosine of the half angle is equal to negative square root of 3 over 2. All right, so we're just going to solve for this angle. It's a half angle, but it's still just an angle, so let's just solve for it. So unit circle, cosine is the x-coordinate, negative big ratio is going to kind of give us those two spots there. So that is 5 pi 6 plus 2 pi k, and 7 pi 6 plus 2 pi k. However, this is not the angle I want to solve for, so let's double everything. Got to double everything, got to distribute this into the period and everything. So theta equals, that is 5 pi thirds plus 4 pi k, and 7 pi thirds plus 4 pi k. Lastly, we need to realize that we're just looking for angles on this interval. So 5 pi thirds is on that interval. You know, that's 0 to 2 pi is, how many pi thirds? 6 pi thirds. All right. So this one is a good angle. This one is not. And if you add 4 pi k to any of those, you're just going to get angles outside that. So your only answer is this one. All right. So the following equation, this has got a double angle. However, I can't really isolate that double angle because of this cosine here. So I need to use my double angle formula to rewrite it. Look at your formula sheet if you can't remember what it is, but you got to remember it for the test. So that this becomes 2 sine theta cosine theta equals 2 cosine theta. Move the cosine over, 2 sine theta cosine theta minus 2 cosine theta. Factor out a 2 cosine theta, leaves me with sine theta minus 1. Set this equal to 0. Set this equal to 0. Unit circle time. So cosine is the x-coordinate. X-coordinate is 0 at these two spots. Sine is the y-coordinate. Y-coordinate is equal to 1 at that spot. So those are my two angles. So theta equals pi halves plus pi k. Pi halves plus pi k. That gets all of them. Solve the following equation. So this has got a sine, this has got a cosine squared. So this is kind of difficult to isolate the trig function when you have two different trig functions. So what we want to do is we want to write that cosine squared as a sine. And we're going to do that by remembering the identity sine squared plus cosine squared equals 1. Therefore, the cosine squared would just be 1 minus the sine squared. So 1 plus the sine equals 2 times, where I see cosine squared, I'm going to replace it with 1 minus sine squared. Multiply it out. Collect everything on the same side. Kind of switch between x's and thetas there a little bit. My bad. My bad. 1 minus 2 is minus 1. So here, if you don't feel comfortable factoring this, you could do a little u substitution. So it doesn't look like you're having to factor signs, I guess. I don't know. That's certainly not needed, though. I'm just going to factor it. 2 times negative 1 is negative 2. Factors of negative 2 that add up to 1 is a positive 2 and a negative 1. So this factors into 2 sine x. Sine x. So I'm going to make the outside product positive 2. Make the inside product negative 1. So the sine of x is equal to 1/2, or the sine of x is equal to negative 1. Unit circle time. Sine is the y coordinate. Y coordinate is a half at the two 30-degree angles, and it's equal to -1 at this one. So we actually get these three. So x is equal to, now you could just write this out as 3, pi 6 plus 2 pi k, 5 pi 6 plus 2 pi k, but you could actually go pi 6 plus, this is 120, 120, 120. They're equally spaced. 120 is 2 pi thirds k if you wanted to get fancy and put it as one answer. You don't have to do that. You could list them as all three. All right, next one. So this one, this one's a little more difficult because it's, you got sines and cosine just like the last one, but this had a cosine squared, so it's easier to isolate. This doesn't have a squared, so it's a little harder to. Like you could, there's a lot of different ways you can do it, I guess. I'm just going to come right out and do it. We talked in class at more length about what should we do and what if this, what if that. I'm just going to square both sides. Remember, when you square both sides, you get extraneous solutions. So we're going to have to check our answers at the end. It's going to add some complexity. Square this, that is cosine squared x plus 2 cosine x plus 1 equals sine squared. So now I got a cosine and cosine squares. Let's make this a cosine. Cosine squared x plus 2 cosine x plus 1 equals 1 minus cosine squared x. Collect everything on the same side. That's 2 cosine squared x plus 2 cosine x. Ones go away. Factor out a 2 cosine x. Leaves me with a cosine x plus 1. Set this one equal to 0. Set this one equal to 0. Unit circle time. Cosine is the x coordinate. 0 those spots and -1 at this spot. However, I gotta check these bad boys. So the way that, ooh, what happened there? Where'd my stuff go? Ooh. Did some crazy zoom in there all of a sudden, my bad. So my base solutions are pi halves, pi, and 3 pi halves. So, but it's plus 2 pi k, so we got these infinite solution sets. But the way this works, and we got extraneous solutions, so we got to check our answers. So it's impossible to check an infinite solution set, but basically, if you check the base solution, then and it works, then every coterminal angle with it will work. And if you check the base solution and it doesn't work, then none of the coterminal angles to that one will work. So basically, we just got to check these individually. So we're checking with the original. I'm just going to plug, these points. So plug in this point. The coordinates of that point are 0, 1. 0 is the cosine, 1 is the sine. So cosine is 0 plus 1, and then the sine is 1. So that one checks out. This point is -1 comma 0. So the cosine is -1 plus 1 equals, and the sine is 0. That one checks out. This point down here is 0 comma -1. Cosine is 0 plus 1. Sine is -1. Does not check out. However, notice if you square both sides, those would be the same. So those set solutions aren't good. And so my final answer is pi halves plus 2 pi k and pi plus 2 pi k. Okay, last one. So I'm going to write everything in terms of sines and cosines, just to kind of clean it up a bit, because I got secants and tangents and cosines. So the secant is 1 over the cosine, plus the tangent is, oh, it's minus, I would have messed it all up, minus the sine over cosine equals cosine. So let's get a common denominator here, 1 minus the sine. I guess we already have a common denominator, I'm just combining it. This is cosine theta over 1. Cross multiply, cosine squared theta equals 1 minus sine theta. Now, when you cross multiply, what I'm really doing is multiplying both sides by the cosine theta. when you do that, you could introduce extraneous solutions. So we do have to watch out for extraneous solutions again. All right, we'll plug in the sign here. 1 minus sine squared theta equals 1 minus sine theta. I'm going to collect things on the right. So 0 equals, 1's go away. Got the sine squared theta minus the sine theta. Factor out the sine. So set this one equal to 0. Set this one equal to 0. Unit circle to m. Sine is a y-coordinate. Y-coordinate 0 here and here. It's also 0 there. So we got 3 solutions. But I have to check them with the original. So I got to check 0. Got to check pi halves. And I got to check pi. So let's do it. So at this point here, coordinates are 1, 0. So the secant is the reciprocal of the cosine. The cosine is 1, so that would be 1 minus tangent is 0 equals the cosine is 1. That checks out. Pi halves. This is 0, 1. So the secant is a reciprocal of the 0, which is undefined. So this one doesn't work. This point here is negative 1, 0. Secant is going to be negative 1 minus the tangent is 0 equals a cosine, which is negative 1. Right, so apparently the pi halves doesn't work, but the 0 and the pi do. So my answer is theta equals pi k. Technically 0 plus pi k if you want, but pi k. Pi k. Right, there we go. Done deal. 12 minutes. Man, I should just do my lecture like that.